All right, let's start looking at the warm-up. So on number 1, there's a couple different things that I noticed. There are 2 triangles in number 1. There is this top little triangle up here. And then there is the larger triangle here. So I do have 2 triangles. I got a little one and a big one. We need to determine whether or not these triangles are similar. And I've almost blocked it out, but there's these 2 little arrowheads here. One of the first things I notice on number 1 is when I look at triangle ACD, the big one that I have outlined in black, and ABE, the little one that's outlined in orange, there's something that they have in common. What do they share between those 2 triangles? What's the same between those 2 triangles? Angle A. We have a shared angle. It would be congruent to itself. And then it also has these parallel line markings on it. Most of the time, when we see parallel line markings, it's been in a picture like on number 2. And I can go in and draw that Z shape and try to find my alternate interior angles. Those aren't the only pairs of angles that we can look for when we have parallel lines. Let's write down some of what we've got. Parallel line angle pairs. There were 5 angle pairs that we studied in the first semester that are very specific to parallel lines. One of those, are alternate interior angles. And this is the one where we can go in and draw the Z. And we get these angles right here. Those are my alternate interiors. Does anybody remember any other special angle pairs from when we did parallel lines? Alternate exterior angles. These pairs are pairs of angles that are congruent. Does anybody remember any other special angle pairs from when we studied parallel lines? There was consecutive interior angles. And there were consecutive exterior angles. Those were both supplementary. And there was one other angle pair when we studied parallel lines. And that was, what'd you say? Vertical angles we did talk about when we talked about parallel lines, but I don't have to have parallel lines to get vertical angles. I just have to have 2 lines crossing each other. The other kind of angle pair was corresponding angles. And corresponding angles, if you have 2 parallel lines cut by a transversal, our corresponding angles will be on the same side of the transversal, but one would be an interior angle and one would be an exterior angle. It's like those 2 right there. And when I look at number 1, I see corresponding angles. B and C are corresponding angles. Or we could have said which 2. What other 2 are corresponding? E and D. So B and C are corresponding angles, or you could say E and D, either of those. So are these two triangles similar? Yes. Using which type of similarity? Angle, angle, side, 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 or side, angle, side? Using angle, angle. To use side, angle, side, I have to actually have measurements for two pairs of sides between these triangles. So now we have to write our triangle similarity statement. Triangle. I'm going to call the first one A, B, E. The way we name the first triangle does not matter, so I've named my little triangle first. I'm saying that triangle ABE is similar to, well, angle A in my little triangle is congruent to what angle in my big triangle? Same one, A. Angle B in my little triangle is congruent to which angle in my big triangle? C. And angle E is congruent to D. So triangle ABE is similar to triangle ACD by angle, angle, similarity. Number 2, did they give us any side lengths on either of these triangles? No. Then I'm not going to be able to use side, 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 because I have to have side lengths to compare for side, side, side. And I'm not going to be able to use side, angle, side either, because again, I have to have at least 2 pairs of corresponding sides to use side, angle, side. So I can't use either of those. So I'm going to have to look for angle, angle similarity. Do you guys see any angles on these two triangles that would have to be congruent to each other? Vertical angles right here, angle L on the top and angle L on the bottom. Our vertical angles are congruent. And I notice once again, we've got these little arrowheads, JK and NM. What do those arrowheads mean again? Means parallel. I can't find corresponding angles on this one, but I can find alternate interior angles. I'm going to draw a Z shape to help me find my alternate interior angles. Those alternate interior angles are going to be tucked into those corners of my Z. So like right here, angle K. And down on the bottom one, that would correspond to angle M. So those are my alternate interior angles. I could also have taken my Z and drawn it the other direction. We could have gone from K to J, J to N, and N to M. And then I still would have had alternate interior angles, but it would have been J and N instead. Let's write our triangle congruence statement. Sorry, not congruence, similarity. Triangle similarity statement. Let's call the top one JKL. Triangle JKL is similar to, angle J would be congruent to what angle on the bottom triangle? N. What about K? M. And L? Not necessarily to itself, because it's not the same angle L, but it's angle L on the top triangle to angle L on the bottom triangle. Using which of those triangle similarity postulates? Angle, angle, side, 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 or side, angle, side? Using angle, angle similarity. All right, last one on the warm-up, number 3. We are supposed to find X. I notice on the picture that these two top angles are marked as congruent to each other. Are there any other congruent angles here? Yes, which one? Or ones, rather. Vertical angles, right here where it makes that X shape. Those angles are congruent to each other. So these two triangles are similar by angle-angle similarity. All right, let's try to set up and solve a proportion. We need to find x. X is right here. And then I need to find the side that corresponds to that because they're going to make a fraction together. When I look at where x is on this smaller triangle, I notice it's in between these two angles that are marked with 1 and 2 congruence marks, respectively. The corresponding angle on the other triangle would have to be in between the same two or similarly marked angles. What is the corresponding side for x? 5 down here? Is that in between the 1 and the 2 marks? Congruence marks. No. Which side is between the 1 and the 2 congruence marks? The 3. That would have to be the corresponding side because it has the same relative position on the other triangle. It's in between two angles marked with congruence marks. So on the other triangle, we have to be in between the two angles that are marked with those congruence marks. So one of my fractions would be x over 3. And so that means that 3 and 5 have to form a fraction together. Those are corresponding sides between the two triangles. Which one's going to go on top, the 3 or the 5? The 3 has to go on top because x from that same triangle is on the top of this fraction here. So I would have 3 over 5 for my second triangle, or sorry, for my second fraction. 3 over 5. So I have my proportions set up. I have my two fractions. I want to get x all by itself. What operation will undo fractions for me? Multiplication. What part of the fraction do we multiply by? The denominator. So what are we going to multiply here to get x all alone? 3. Multiply the left side by 3, and we multiply the right side by 3. My 3's cancel out there. I have x equals, when I multiply a fraction and a whole number together, the whole number only distributes to my numerator. So I would have 3 times 3 on the top, or 9, over 5. Does 9 over 5 reduce at all? No, there's nothing that goes into 3 that also goes into 5. But I could write it in its decimal form if I didn't want to leave it in its fraction form. Can you guys grab a calculator, cell phone calculator is fine, and do 9 divided by 5 for me? What'd you say? 1.8, thank you. So the value of x on number 3, I could either write as 9/5 or as 1.8. Those would both be considered correct answers. All right. Nice work on the warm-up. I need everybody's phones put up for me. We're going to be in your extra notes first, and then we're going to be in your book. So please pull both of those out. Extra notes and your book. We were on page 7 in your extra notes. We were working through part B of number 3. We had left off right here. So this is page 7, part B. As soon as Greg gets back. All right, we'd gotten our two proportions set up. We saw that our two triangles were similar to each other by angle-angle similarity. JL corresponded to LM, and JK corresponded to MN. So we got x plus 18 over x minus 3. And then for my other fraction, we had 16 over 4. Just like we were doing on the warm-up, I want to get rid of my fractions first. To get rid of a fraction, we use what operation? Multiplication. And what part of the fraction do we multiply by? always the denominator. I've got two different denominators. We have to make a choice here. Which one do we want to multiply by first? The x minus 3 or the 4? 4 sounds good. It does not matter which one you pick. You just have to make a choice. So we're going to multiply both sides by 4. That's going to cancel my denominator on the right, and that 4 will only distribute to the numerator. So I would have 4x plus, what is 4 times 18? 72. So 4x plus 72 over x minus 3 equals 16. And now we have to get rid of that other denominator. So now I have to multiply both sides by what? By x minus 3. Here. So my x minus 3's cancel out on the left. I have 4x plus 72 equals, I have to distribute this 16 to both the x and the minus 3. So I'm going to have 16x minus what? How much? 48. 16x minus 48. All right, I'm going to need a little bit more space because I ran out of room at the bottom. So I'm going to bring my work over here. 4x plus 72 equals 16x minus 48. My x's are on opposite sides, so I need to get them to the same side. We're going to subtract 4x from both sides to get our x's on the same side of the equal sign. So I would have 72 equals what? 12x minus 48. Have to undo any addition or subtraction that we have on the same side where x is. So we're going to add 48 to both sides. What is 72 plus 48? 120. So 120 equals 12x. Divide both sides by 12. X equals 10. Nice work. There's one last problem in this extra notes packet that we're going to do before we switch over to your book. And this one is about a father and a son and their shadows. We had a warm-up question last week on Thursday that was very similar to this. Do you guys remember the question where we had the painter that was painting the building? And they were trying to figure out how tall the building was. We knew how big their shadows were on the ground. So this father and son problem is almost exactly the same as that. So we have our father. And what do we know about the father? He's 6 feet tall. So I'm going to go ahead and put that right here. Do we know anything else about the father? His shadow is 14 feet. So here's his shadow. 14-foot shadow. If he's casting a shadow, then the sun has to be somewhere. And those sun's rays would make the third side of our triangle. Father standing up straight on the ground, so him and his shadow are making a right angle. And then we have the sun. What do we know about the sun? Not the sun in the sky, but the father's son. He's 4 feet tall. How long's his shadow? We don't know. He is casting a shadow, though. And just like Dad, it's making a right angle with the ground. Since I don't know how big the shadow is, I'm going to call it X. That is what we've been asked to find in this problem. How long is his shadow? So we're going to set up some proportions. These are similar triangles. The sun's rays are at the same angle for both the father and the son, and both the father and the son are making right angles with the ground. So I'm going to set up a proportion. Let's do x in one of our proportions, and that would correspond to what on the other triangle? The shadow length, 14 feet. So we're going to have one fraction that's talking about our shadows. Son's shadow over father's shadow, x over 14. What should our other fraction look like? 4 over 6, son's height over father's height. So the son is in the numerator for both of these, and the father's in the denominator for both of these. I've got two fractions here. X is part of a fraction. What do I need to do so that the x will be all alone? Multiply by 14. So we're going to multiply both sides by 14. It's going to cancel out my denominator on the left. So I'll have x all alone on the left-hand side. That 14 is only going to distribute to the numerator. What is 4 times 14? 56. So I have 56 over 6. Pop that into your calculators for me. What is 56 over 6? 9.3 repeating. So 9.333333333. When they said how long is his shadow, to answer that question, I would say the sun's shadow is, and then I'm going to do some approximating. I'm going to do some rounding. So I'm going to say his shadow is about 9.3, and what kind of units would go with that? Feet. The sun's shadow is about 9.3 feet. Once you finish that getting into your notes, go ahead and put your notes up for today and grab your books. We're going to be on page 477 in your book. 477. .477. We're down towards the bottom of the page. We're looking at example number 1. The two triangles right here in this first image. We have this little inside triangle, LPQ. And then we have the larger outside triangle out here, LJK. And similar to our warm-up problem today, I noticed that these two triangles have a shared angle, angle L. Because it's part of both triangles, we can say it is congruent to itself. What did we use in proofs from first semester to say that a shared side was congruent to itself? Does anybody remember? What property did we use to say that a shared side was congruent to itself? Reflexive, yes. So a shared angle would be congruent to itself by that same property. The reflexive property tells me that that shared side is congruent to itself. And then it tells me that we have some corresponding angles. It says angle LPQ, that's this angle right here, is congruent to, what would the corresponding angle on the large black triangle be? J. These are corresponding angles. Corresponding angles are also congruent. So angle LPQ is congruent to angle J. So by angle-angle similarity, triangle KLJ is similar to triangle QLP. I want to do the check down at the bottom. Do we have side lengths for either of these triangles? No. If there are no side lengths, then the only kind of similarity I can look for is angle-angle similarity. Do these two triangles have any angles that are the same size? Yes. Which one? Right angles. Well, the other two angles, 44 and 47, those don't match. So does that automatically mean that these are not similar triangles? No. I need to figure out how big those third angles are in each triangle, and then I can look to see whether or not they are similar. How many degrees does a triangle always add up to? 180. All right, so let's find angle A first. I have 90 degrees plus 44 degrees plus the measure of angle A. That adds up to 180 degrees. What is 90 plus 44? 134. So 134 degrees plus the measure of angle A equals 180. It's minus 134 degrees from both sides. And so angle A would be how big? 46 degrees. Do I have enough now to say that these two triangles are similar or not similar? Or do I need to do a little bit more? "44 doesn't match 47, and 46 doesn't match 47. Remember, we have to have 3 pairs of corresponding congruent angles in similar triangles. I only need to check that 2 of them are congruent. So since 46 is not the same as 47, and 44 is not the same as 47, these triangles are not similar. There's only one pair of congruent angles. We are going to skip forward to page 481. While you guys are flipping over to 481, I want to remind you that on problems like this, just because this time they came out to not be similar, doesn't mean that the next time you see a problem like this, it wouldn't come out to be similar. You always need to check. Find any missing angles, if possible, before you decide whether those triangles are or are not similar. All right, let's flip over to 481. Page 481. So that's more than one page forward. Your book has a whole bunch of work right in here that is absolutely doing too much. So I want you guys to write in the right-hand margin. Do we have any angle measurements between these two triangles? Are there any angle measurements given? Nope. If there's no angle measurements given, I can't look for angle-angle similarity because I don't have enough information. And I can't look for side-angle-side because I have to have at least one pair of congruent angles to do side-angle-side. So I want to check for side-side-side similarity here. Write this down for me. When using or checking for side-side-side similarity, you want to match the smallest and largest sides from both triangles. All right, so let's practice matching these guys up. What is the smallest side on this left-hand triangle? 8. What is the smallest side on the right-hand triangle? 6. So those are going to have to make a fraction together. Those are corresponding. So I can do 8 over 6, or I could do 6 over 8. What is the largest side on the right-hand triangle? 16 is our largest side. What's the largest side on the other triangle? 12. So I would have 16 over 12. And then what are my leftover sides, the medium-sized sides? 12 and 9. Which one has to go on top? 12, because I've got my big triangle sides on top, my small triangle sides on the bottom. Can somebody grab a calculator for me? I want to know what 8 divided by 6 is. 1.3 repeating. What about 16 divided by 12? Same thing, 1.3 repeating. 12 divided by 9? You got what? 1.3 repeating again. Those all came out to be the exact same proportion. So these two triangles are similar. Triangle, let's call this first one JLK, is similar to, when we're doing side, 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 it can be a little bit hard to write these similarity statements. But I do notice on this larger triangle that angle J is across from my smallest side. Which angle is across from my smallest side on the other triangle? Q. So J and Q would be congruent angles. Angle L is across from my largest side. Which angle on the other triangle is across from the largest side? Which one? M, thank you. And so that just leaves K. K is across from the medium-sized side. Which one over here is across from the medium-sized side? We already used Q. We already used M. So it would have to be P. These are similar by side, side, side similarity. Flip over to page 482 for me. We're going to look at example number 2. Please do your work in the margin. In the left-hand margin this time. We have a shared angle M up here. And then we have corresponding angles, Q and P. So these two triangles are similar to each other by angle-angle similarity. They want us to find the lengths of side QN, this one right here, and PO, this one down at the bottom. So I'm going to redraw those two triangles. I'm going to draw the small one and the large one. There's the small triangle. There's the large triangle. The small one has vertices Q, M, and N. And its sides are 5, 6, and X. The larger triangle has vertices P, M, and O. Down at the bottom, it says X plus 2 1/4. What is 1/4 as a decimal? 0.25. So the bottom I'm going to rewrite as X plus 2.25. How big would side MP be? 8. We've got the 3 and the 5 together, so this would be 8. I could do this side over here, but I don't necessarily need it. I need 2 pairs of corresponding sides if I'm going to set up a proportion to be able to find X. This side right here, QN, would correspond to what side on my larger triangle? PO. So I would have X over X plus 2.25. And that would be equal to, now I need another pair of sides. MQ would correspond to what on the larger triangle? MP. So my other fraction would be 5 over 8. What do we need to do to get rid of fractions? Multiply. Which fraction do you want to get rid of first? The X plus 2.25 or the 8? 8 is the first one that I heard. It does not matter which fraction you decide to get rid of first, which denominator you decide to multiply by. What you do need to remember, though, is that when you multiply by a denominator, it's only going to distribute to the top. So that would be 8x over x plus 2.25 equals 5. I still have a fraction, so what do I need to do to get rid of it? Multiply. What are we going to multiply by? X plus 2.25 on both sides. Cancels my denominator here. That 5 is going to distribute to these two pieces. So I would have 8x equals 5x plus, what is 5 times 2.25? 11.25. Subtract 5x from both sides. What is 8x minus 5x? 3x. What is 11.25 divided by 3? 3 point what? 75. The question asked me to find QN and PO. We found QN. To find PO, we would add 2.25 to that. Homework is due tomorrow. If you need another copy of the homework page, it is second one up in this red organizer. Have a fantastic rest of your day, guys, and I will see you tomorrow with your homework.